is acidification? Ocean acidification refers to reduction in pH of the ocean over an extended period of time, caused primarily by the uptake of carbon dioxide from the atmosphere. Why is ocean acidification occurring? Over the years, carbon dioxide concentrations have been increasing continuously due to human actions. CO2 is a very important gas in our atmosphere. It keeps our planet warm and can easily dissolve in water. Since the pre-industrial era, humans have managed to increase the concentrations of carbon dioxide by 50%. Currently, the atmospheric CO2 is 425 ppm. How does this impact the ocean's biogeochemical cycles? Fortunately, the ocean is a primary sink for CO2. Nevertheless, this means that more and more CO2 is being dissolved into the oceans. When CO2 diffuses into seawater, it combines with water to form carbonic acid, a weak acid. Then the weak acid dissociates into hydrogen ions and bicarbonate ions. As the weak acid dissociates, hydrogen ions are released. The more hydrogen ions present in the ocean, the more acidic the seawater becomes, which decreases the pH. This leads to ocean acidification, which harms several marine species. Hydrogen ions bind with carbonate, reducing the abundance of calcium carbonate building blocks needed for calcifying organisms to build their shells. Since the pre-industrial revolution 200 years ago, the pH of the ocean has decreased by 0.1. The pH scale is measured on a logarithmic scale, meaning that a 0.1 drop is actually a 30% decline in pH. Decreasing the strength of the carbonate biological pump can cause problems for the carbon cycle as a whole. Sinking carbonate matter from dead calcifying organisms is important for carbon sequestration. With decreasing amounts of calcium carbonate, we will see a potential decline in carbon sequestration and shallowing of the carbonate compensation depth. One species that is at risk is known as Pteropods, or sea butterflies. These small marine organisms have delicate, translucent shells that can easily dissolve by the slightest change in acidity. Pteropods are marine calcifiers. They use carbonate and calcium ions to build their shells. However, as pH decreases, the number of available carbonate ions decrease. These small planktonic gastropods are important for balancing the carbonate cycle and carbon fluxes. The absence of pteropods will disrupt the food web because they make up the base of the food pyramid. For example, in Washington, the southern resident killer whales mainly feed on Chinook salmon, but the salmon feed on pteropods. The question is, how will this impact the killer whales and the salmon populations? Additionally, sea butterflies provide a source of fatty acids to juvenile fish. Without this food source, the fish would not be able to attain these fatty acids, potentially leading to delays in development of fish. As the ocean continues to acidify due to the rise of anthropogenic CO2, we will likely see a decline in pteropod population in various oceans. But what should we do to solve this? One way to reduce CO2 emissions is to support and pass legislation that will act on implementing ways to reduce the use of fossil fuels. By working with scientists and advocating for a cleaner future, we can significantly reduce the harm to marine ecosystems.
Created using Powtoon.